Okay. Actually, I got late because I was talking to my guide. Let's start. So we have completed so far 3 modules, that is the stakeholders and principles of flight and the ATC procedures, radio telephony. Okay. So far, any questions you have on this, any of these 3 topics, anything which you want to be revised or you need more details? End of this session, I will also be sharing some pictures, some images which will be helpful for you, very important images which will be on the group. I'll be sharing you to you regularly. I'll be sharing you to you as we progress over the theory sessions, which I feel very important, or you should always have yourself available for you any point in time to know them. Okay. If you have anything in your mind, please communicate to me accordingly so that I can take up, or we can start off with the next topic is fixed wing operations and aerodynamics. Okay. So fixed wing operations or aerodynamics is nothing but it's your aeroplane operations or aerodynamics. How actually the aeroplane flies. Here the fixed wing is, the aeroplane is having a fixed wing. Okay, the wing cannot be changed or cannot be moved and all that things. Okay, so using the fixed wing, how the operations can be conducted and how the aerodynamics happens in here. Okay, so what are fixed wing drones? Fixed wing drones are the aeroplanes which generate the lift under the wing due to the forward airspeed which is produced by either an internal combustion engine or electric motor mounted with the propeller. So if you see the fixed wing, okay, it will generate the lift under the wings due to the aerodynamics and the forward airspeed motion. So how that forward motion is happening? Either by using 2 engines. One is the internal combustion engine, what you can see here, okay, or the electric motor. Okay, depending upon what. Both are being connected to the propellers. There will be a propeller in the front of the both, okay, and which will be rotating and which will giving it the forward speed. Okay, the forward speed and the aerodynamics shape of the aeroplane will cause this fixed wing drone to move in the air, okay, or generate the lift in the air. They will require either a handheld catapult or runway takeoff and can fly continuously over long distance as opposed to hovering. So not like a normal rotor craft, these drones will be normally either catapult, okay, handheld catapult, or there will be a mechanism to catapult. You would have seen recent times in the war also these type of drones were used, right? The catapult drones or all those things, or even you can see a small drones which are used for surveillance and all those things. They can be also either catapult using the handheld. Okay, they can fly longer distances. Okay, continuously longer distance they can fly, but they cannot hover. Okay, like if you see the Predator drone over here, okay, this can fly almost for 2 days. Okay, 1 day or 2 days, it can continuously flying. This drone was used in Afghanistan very extensively. It's a very tested drone of it, and it is the very old drone. I mean, there is a lot of research has gone on this drone, especially this is called as Predator drone. Okay, so there are different types of fixed wings: straight wings, rectangular straight wings, tapered straight wings, or round or elliptical straight wings. So as you see the shape, the rectangular ones, okay, they are less efficient. As the shape changes, they become very efficient. If you see the round or elliptical straight wings, they are very highly efficient. Can you tell me the example of these highly efficient rounded elliptical straight wings used when? Have you seen any kind of aeroplane with this kind of wings? Any idea? No?
Something like B2 bomber, I don't know.
B2 bomber, not like a round or elliptical straight wings. If you have seen aeroplanes during World War II, right, Mustang, B-51, or maybe Spitfire, you know, those aeroplanes which were used during those eras, they were using rounded or elliptical straight wings. Okay, so they were very efficient, but these type of wings, shape of the wing can be done in a smaller aircraft, not in a bigger aircraft. Okay, it has its own drawbacks also over there. What is next? Next is the swept wing. Okay, these are very highly efficient, slightly swept wing, moderately swept wing, and highly swept wings. Okay, so depending upon the requirement and all the things, the design of the swept wing is being utilized based on the power and the aircraft it has been designed. So either it could be slightly swept wing, moderate, or highly swept wing. Highly swept wings are very highly efficient or very fast aeroplanes. Okay, especially the jet engines and all the things are been using this type of swept wings. The third one is the delta. Okay, delta are simple delta wings, the normal delta wings, or complex delta wings suitable for high subspeed subsonics or supersonic flights. Okay, so you will see these are mostly the military aircrafts or bombers what is being used, where you need to be very stealth and low flying, but very high speeds. At very high speed you are doing supersonic or subsonic levels you want to fly. So that time you will have this type of wing shape. Okay, whereas if you see this kind of slightly swept wing, okay, these you will normally see in commercial aeroplanes. Okay, the longer one, okay, the bigger wingspan, slightly swept wing. Okay, those you will see in a commercial where your speed is not important. Okay, or you don't need to fly at very high speeds. Okay, very high speed you have to keep your wings shorter. But if you're flying for a long, you need to have a big glide, you need to have big flight levels, then you will go for slightly swept wings or maybe moderately swept wing, depending upon the size. Again, it depends. There are a lot of other parameters also required when you are designing the aeroplane. Okay, the width of your fuselage, capacity of fuselage, and all that thing. So the glide ratio, flight to the glide ratio, what we call, that is what has been taken into account when we are designing the. So what are the parts of the fixed wing? So you have wings, you have a fuselage, okay, then you have a propellers with the engine, okay, then you have wings with ailerons, then you have a vertical stabilizer, okay, and then you have a horizontal stabilizer. So on horizontal stabilizer you will have elevators, on vertical stabilizer you will have radars. So elevator will actually change your pitch up and down. Radar will change your direction, okay, or your yaw motion. Ailerons will actually help you to roll motions, okay, roll right or roll left. Okay, fuselage will actually, if you see the belly of the fuselage, you will have the payload. Okay, the payload could be probably a camera, high-end camera, surveillance cameras, thermal cameras, lidars. All that things will be fitted over here. Okay, on the belly of the fuselage, and then on the wing, somewhere where fixed wing drones. On the wings there could be some missiles would be there, or any if it is attacking drone kind of thing, depending upon the purpose of the drone. Okay, if it is a surveillance, then only you will have certain fuselage on the certain payloads on the fuselage. Okay, whereas if it is like a loitering or what is it called, kamikaze kind of drones are there, then it could also have ammunition attached to its wings or even on the belly part also. Okay, so depending upon the usage of the fixed wing UAS. Okay, but maximum fixed wing UAS initially was used for surveillance or reconnaissance missions over the enemy territory. So you fly these drones at very high altitude, which is not visible from the ground for the people, and then they will take the survey of that area completely and then return back with the data. Okay, that purpose was the fixed wing UAS. But currently even the fixed wings are being used for dropping or taking the ammunitions also. Okay, at a very high altitude you can fly low down and then drop your ammunitions, and then you can come back safely. So what are the components of the fixed wing RPA system? Propulsion system, fuel system, control system, avionics, takeoff and landing system, and payload systems. Okay, so these are all the points which are required when we are considering the fixed wing RPA. So let's see what is the first propulsion. So first propulsion system is the brushless direct current motor. Okay, so BLDC what we called. Okay, in BLDC it is a high power to weight ratio available in wide range starting from 5 grams. So that motor, what we see, it is even smaller. Tiny motor will be also there. You can build with that tiny motor a fixed wing aircraft also. But these are best suited for nano macro categories, small categories for recreational purposes or small activities purposes, because there where you will have a low noise helping keeping low profile stealth operation, but their endurance will not be very high. So this flight of this kind of fixed wing aircraft will be max to max, I would say 30 minutes, not more than that. Higher side it could be 60 minutes, but then again the weight will come into the picture, okay, because the more power you are trying to give it to it, more endurance capacity you are trying to give it, it will become more heavier. But if you see, instead of brushless DC motor, you are using IC engines. Okay, IC engines conventionally used system. Okay, provide high endurance than BLDC, because that's why if you see the Predator drones or the drones which are flying for more than hour, okay, maybe like 8 hours, 10 hours, 24 hours, 48 hours, they are using IC engine. Without IC engine, you cannot fly fixed wing uh, for that much of endurance. Okay, if you try think that I use brushless DC motor, it is next to impossible. Okay, so because the amount of battery power required for the drones to carry it will be huge, which is next to impossible to make it fly for 48 hours or 24 hours, even 10 hours. Forget about 10 hours, even thinking about 1 hour is a big task in itself. So right now we do not have any as such drones which uses, unless they have been designed specifically for certain particular activities. Okay, maximum using brushless DC motor you can fly max to max 30 minutes to 60 minutes, not beyond that. Okay, it's not possible in the current batteries what we have available. Okay, whereas IC engines is they use a propulsion system, okay, using the fuel, okay, type of fuel it is used, you can always fly as much as required. Okay, and this any of these motors, whether it is BLDC motors or IC engine motors, both uses propellers. Okay, so propellers are connected to the BLDC or IC engines. They provide the thrust by rotating in size, particular direction. Made these propellers either are made of wood or industrial grade, small grade plastic, or even carbon fiber. Okay, so that is how these propulsion systems are being using propellers. Okay, so if you see olden vintage aircrafts which are used in World War I and II, that time you would have seen that they were using wooden made propellers. Or as we technology progressed, people were able to make better propellers. People were started using, some were initially started using aluminum grade or lightweight material for propellers, but that was not successful because it was adding weight and it was not giving that efficiency or that motions. Okay, it has to be very light. The propeller has to be very light. Okay, but still at what speed it is rotating, it needs to be stronger also. Okay, so carbon fiber is most suited used, but then as we are using carbon fiber, it is expensive. Okay, or small grade plastic is also being used. Okay, hardened plastic is also used, or even currently I think there are graphene what is being used and all the thing. But then as we use the high standard materials, it becomes very expensive. Okay, so in a smaller drones we cannot use. So normally in a smaller drones, maybe a capacity of like 5 kg, 10 kg of fixed wing, you will normally use either carbon or industrial grade plastic is used. Okay. Now let's see what is power system or fuel system we'll use. For BLDC, we'll be using lithium based batteries. Either LiPo or lithium ions are the most widely used batteries. LiPo batteries can be custom but differ in shape and size. Lithium ion batteries are capable of higher endurance capacity or higher endurance flights. Okay, energy density is far less than engine. Whatever the best of the best batteries what we use, still their energy density is less compared to the IC engine, because the amount of weight of the lithium is too much compared to the liquid fuel. Whereas liquid fuel is stored in a tanks mounted in a fuselage or in the wings also. Okay, depending upon how you have designed the fixed wing. It could be a glow, nitro fuel, gasoline, or diesel is used as a fuel. Okay, here we get better thrust to weight ratios than lithium based batteries. Okay, the amount of, let's say, 10 liter in 10 liter tank, it will not weight much. Okay, compared to a 10 kg of batteries. Okay, it will be very expensive. It will be very costly, and the amount of lithium what will be used will be expensive compared to here liquid fuel what we are using. It's a simple tank, plastic grade, carbonate grade tank which is there, and using from IC engine is used. So you get a better thrust to weight ratio as well as the longer endurance capacity you get it in a liquid fuel. Apart from lithium batteries and liquid fuel, there are alternate options are being tried and tested right now is hydrogen powered aircrafts, fixed wing aircrafts. or even solar powered aircrafts. But this still they are in prototype, they are not in production. Okay, they are still in a prototype in testing phases. There are a lot of tests have been happening, especially on the solar powered fixed wing aircraft. They have been flown across the globe and tested in different conditions and different times and locations and zones to understand whether, because of the sun, whether they are able to power their engines or batteries and the propellers. Okay, so these are still in prototype state. The most important what we use in a fixed wing is always the liquid fuel. The Predator drones, Harpoons, all those are using your liquid fuels only. Okay, so now when you are flying these drones, okay, so these are the controls which you need to know. So when we are managing the remote, okay, you have a remote in your hand. Okay, when you have a remote in your hand, your right side joystick, okay, your right side joystick is called as roll and pitch. Okay, so it is RP, and your left side joystick is called as throttle and yaw. Okay, so your up and down motion is pitch. Okay, your up and down motion is pitch. Your left and right or lateral motion is called roll. Okay, same thing for your left side. Up and down is called throttle up, throttle down, and yaw is your lateral motion. It is yaw left and yaw right. Okay, so you can see here roll, pitch, throttle, yaw. So this is called as RPTY, and this combination is called as mode 2. Mode 2 is being used across the globe, maximum countries. There are only certain countries which are using mode 1 configuration. It is like a left hand drive and right hand drive kind of thing. So everywhere maximum countries uses mode 2 configuration. That is, on right side you have roll and pitch. On your left side you have throttle and yaw. Okay, so remember this. On your right side you have roll and pitch. Okay, so you have a roll motion and pitch motion. Okay, on your left side you have throttle and pitch motion. Okay, so that you have to remember. So this we will be doing in our simulator sessions also, as well as we will be doing in actual practical sessions also. Okay, I know that you people have already flown the drones and you must be aware, but this is the terminology what you need to aware. Like a lot of people learn flying the drones, but they do not know what to be called. Okay, or they do not know what mode we are using the drone. Are you aware that what is mode 2 and mode 1? Mode 1, mode 2, mode 3, mode 4 are there. Okay, there are different combinations are there. So normally we use mode 2 when we are flying our drone, or our drones are being configured for, or our remotes are being always designed for mode 2 configuration. Okay, until unless we have a specific requirement for mode 1 or any other mode we want to use it. Okay, but standard is mode 2 configuration. Okay, so you see channel 1, you see this remote over here. So channel 1 is roll, channel 2 is pitch, channel 3 is throttle, channel 4 is yaw. Okay, so you can see on your right side you have roll and pitch. On your left side you have throttle and yaw. So clear on this? Do I need any further explanation? This is called as mode 2 configuration. Okay, if you reverse this, pitch and roll on your left side and throttle and on right side, it will become mode 1 configuration. Okay, so mode 1 configuration very less people uses. I think some people somewhere in Canada, even in US, some people use it. It's like people who are lefty, you know, they normally use mode 1 configuration. Okay, but if you use it in mode 2 configuration also, it's not difficult, because there is nothing lefty or righty over here. Okay, you have to, you know, just understand your motions, which joystick controls what motions of the drone or the aeroplane. Okay, so that is mode 2. So we remember it as RPTY. Okay, RPTY. Okay, remember this. This will be question asked. Okay, so when we are flying these fixed wing aeroplanes, okay, most of the time when we are flying this fixed wing vehicles, we never fly manually, or we never fly with the remote. It's very difficult, right? If you, unless you are flying fixed wing only for aero modeling, the smaller space you are flying, you are just flying for recreational. But if you are doing some action, you are doing some mission, okay, in that scenario you never fly drone in manual mode or using remote. You will always have a mission planning software. Okay, so what is mission planner? Mission planner is a planning software or a ground station control station for plane, copter or rover. It is only compatible with Windows. Mission Planner can be used on a configuration utility or as a dynamic control system for your autonomous vehicle. That means this software, this is a this is a free open source software. You can download from the net and use it. Okay, you can communicate with the drones and all the things. Okay, if you build any drone yourself, you can use Mission Planner software to learn and do it. So normally engineering students or people who does build their first drones and all the things, they uses this software for learning. But the military grade aircraft or commercial grade aircraft, they have their own software similar to Mission Planning, okay, which is a subscription based software. They are more or less similar to the Mission Planners. Okay, they are more or less similar to the Mission Planner. Look and feel, you may feel similar to it. Okay, but they are subscription based because they have been designed, they have been tested, they have been configured with respect to the device and the remotes and the ground control stations. Okay, so all this works for mission planning. Then once you do the mission planning, you fly the drone, you do data acquisition, area mapping, all that things you do, and then once you get to your data, you do data analysis from the thing. So for example, you have flown a fixed wing aircraft over the enemy territory. Let's say you have flown over the Pakistan area. Okay, so you will fly, you will take the entire pictures, you will get back your drone, land it, you will take the data from the drone and give it to the people who actually will analyze that data. It could be pictures, it could be video images, all that things would be there. Okay, so all that will be there, and then based on that, further activities or further things would be performed by the people. Okay, so when you are flying the drone in mission planning, you have to define the path. Okay, so on the, let's say for on the Google Earth or Google Sky Maps or mission planning, all that software, you will have the maps over available. You can define the start positions, you can define your end positions, you can define the path how you want to. Like for agriculture flying, we normally fly drone like this. So you will start your drone here, it will go like this. Okay, if this same pattern I want to do it manually, it is very, very difficult. It will not be uniform. I'll be utilizing lot of battery power over here. So when we are doing spraying activities, seeding activities, or even surveillance into the drones, surveillance into the what is this called? What is that? Crops. Okay, that time we'll always use mission planning. Just a minute. I'll just. Okay, so drones now may have many functions like monitoring climatic change, to carrying out search operations, or after natural disaster, photography, filming, or delivering goods. Okay, so most of the time we'll be always doing mission planning. So like for example in Bangalore, they are actually trying to deliver from what is that called, warehouse to one particular society. They have taken only one particular society and they're testing it. Okay, so they have defined the corridor, they have defined the path, they have defined the way the drone will fly, up and down, vertical arrangement, everything they have defined in the software, and they are just putting the packet into the drone. Drone is automatically taking off, going to the destination, dropping over the packet over there and coming back. So this is very, very defined way of flying drone. It is not left, right, up, down, anything. It will go as per the planned path. Okay, so that is where you will use mission planning softwares. Similarly, when you are flying a drone for agriculture purpose, also spraying, whether seeding or monitoring the crop, there also you will be planning based on your field area. Okay, so you have to define all those paths into the software, and then only you have to execute. So that is autonomous flying. So even if you see, that's what I told you, that's the third subcategory, autonomous UAS. So in that scenario, you are flying your drone in autonomous UAS. Whereas we are only getting trained ourselves for RPAS. Okay, so that is remotely piloted aircraft system. That means you are actually using your remote. So when you get trained for agriculture drone flying, you will be getting trained on the autonomous RPAS. Okay, autonomous UAS, that is what we call. Okay, so there in that batch or that training, you will be trained, or for surveillance activities you are getting trained. In that you will be trained more in detail about this mission planning software. So not only the mission planner software is there, there is another Q ground control, QGCS. Okay, that is software is also there. So there are a lot of drone deploy. There is a software. There are third party commercial softwares are also available for mission planning. Okay. So how do you take off the fixed wing or landing recovery system? So normally you can take off by using hand launch, or you can do catapult launch, or you can runway to take off and land. Okay, in catapult normally it will land either in a zip line, or maybe a parachute recovery or a net recovery also can be done. Okay, so in handheld and catapult normally recovery is parachute recovery or net recovery or a zip line recovery is also there. Whereas on a runway takeoff and landing, it will normally take off and land on a runway. Okay, that is how your system is there. Parachute is not very effective in the quadcopter because the amount of the height what the quadcopter will fly is less compared to the fixed wings. In fixed wing, we can always have a parachutes, but not in a quadcopter because amount of the time it takes to launch the parachute and come down is very less. Okay, by the time the parachute opens and stabilize, your drone will be always hit the ground. Okay, that's why it is not so successful to have the parachute mechanism into the drones, the quadcopter or what we call as rotorcrafts. Okay, in these aeroplanes or the fixed wing aeroplanes, normally we can have because they fly at very high altitude, 10,000 feet, 20,000 feet. So there we can utilize a parachute for recovery system. Okay, so what are the applications of the fixed wing? Surveillance, agriculture, mapping, constructions, wildlife protections, mining. You know, in all these locations, normally you will use fixed wing aircrafts. Okay, or fixed wing drones. Okay, because here you need more speed, cover more area, and longer range, and at very high altitude. So depending upon your application, you will have your fixed wing designed, or you will be using type of fixed wing. Okay. So for example, if you see this here on your right side, there is a different type of fixed wing, whereas you see here for surveillance purpose, there is a different fixed wing. For mapping or agriculture purpose, there is a different thing. So depending upon your application, even your fixed wing size and the endurance capacity, the payload, all things will come into picture. Okay. So let's see the comparison between the fixed wing and the rotorcraft. So fixed wing is unable to maintain the fixed position because it is always in a forward motion. Can only fly horizontally, that is forward. Require hand or mechanical, that is either you throw that aeroplane in the air by hand coordination movement, or mechanical launch, that is catapult mechanism. But it has longer average flight times, can carry heavier payloads. Okay, greater stability in the wind, generally higher flight speeds. Okay. So this is the advantage. Okay, it can carry heavier payload, greater stability in wind. Like if you have a more wind, still your fixed wing can stabilize. It can fly smoothly, but your drone will try to drift. If there is a heavy wind, drone will always try to drift. So it has to always compensate by controlling the motors or rotors or propellers. Okay, which will actually eat up your lot of endurance capacity. Okay, so both wind hai. So your flight time, which was in normal wind was 15 minutes. In a heavy wind, your normal flight will be maybe 10 minutes only, or less than that also, because more power is consumed to stabilize the drone, because multi-rotors are not aerodynamically designed, so it cannot withstand that wind. It has to counter it. Okay, they are not aerodynamically. So, but multi-rotors are easy to control and maneuver. It's very easy to fly because it can hold on its own position, have the ability to hover. It can take off and land vertically. So these are the couple of more advantage of the drones. Okay, but it has disadvantage of limited flying time, small payload capabilities, less stability in the wind, lower flight speeds compared to the fixed wing. So this is what the difference between the fixed wing and the multi-rotors. Okay, any questions over here?
Yes, sir.
Yeah.
I wanted to ask, during the 3D practical that we will do, we will also learn to use the mission planner software.
No, because we do not have a subscription for that. Okay, it's a paid software. Okay, not the mission software, mission planner I can show you on my laptop, but I cannot connect to the drone. Okay, for connecting to the drone, it requires a subscription. Okay, and
Okay,
then
sir.
we cannot use third-party mission planner software to the commercial drones or type certified drone. They have their own mission planner softwares. Okay, which we need to purchase it. But I can show you the mission planner software on my laptop. Okay, how does it look and feel and all that things. Okay.
Okay, sir.
Have you used any point in time mission planner software earlier?
No, sir, I haven't used ever.
Not used. Okay. So I will show you. I'll try to show you, or I'll have some content to share it to you. I'll share it to you guys. Okay. So with that, we complete our topic on the fixed wing aerodynamics and operations. Okay. So let me stop this. Yeah, 5:30. Next topic is about the fixed wing. Okay, this might little bit take overshoot 6 p.m. I hope everybody is okay for that.